Let's talk about parametric equations here. In the blue box, yes, we are describing parametric equations, but before I jump into the formal definition, let's just first look at this first example. It'll make more sense. Yes, I see this is doubled up. All right, so here I have two equations. One is x equals 2 cosine of t, and another one, y is 3 sine of t. So when we're going to graph this, there's technically 3 variables, right? So when I'm making my table of values, I'm going to have a t, I'm going to have an x, and I'm going to have a y, okay? Now, when it comes to graphing, I am only going to plot the x-y pair on my Cartesian coordinate grid here, okay? So it's telling me that my t values go from 0 to 2 pi. So I'm going to probably run out of room. I'm writing a little bit big, but if t is, say, 0, then x is going to equal 2 cosine of 0, which is a 1, and y will equal 3 sine of 0, which is 0. So the coordinate point is going to be 2, 0. Okay, which is right here. All right, let's keep going. I'm going to try to make, maybe a little bit bigger jumps in my table just because I don't have a lot of space. So I'm going to go by, I don't know, quarters, a pi. So 1/4 pi, x will equal 2 cosine of pi over 4, which is going to be root 2 over 2. So we're going to get root 2. Y is going to equal 3 sine of pi over 4, which is root 2 over 2. So root 2 is about 1.4. 3 root 2 over 2 is about 2.1. So I'm going to plot root 2 and then 3/2 root 2, which is going to be about, when I'm plotting, about 1.4 and about 2.1. So about right there, okay? Now, let's keep going. Here, let's do pi over 2. I think you get the hang of it, but let's just keep going because the graph is really where we're going to find some interesting things. X is going to equal 2 cosine of pi over 2 is 0. Y is going to equal 3 cosine of pi over 2, which is 1. So this point is 0, 1 that we'll plot. 0, 3 that we'll plot. Right there. Okay. Let's just go a couple more. 3/4 pi. X is going to equal 2 times a negative root 2 over 2. So we're going to get negative root 2. Y is going to equal 3 times sine of 3 pi over 4 is root 2 over 2. So we're going to plot negative root 2, which is about negative 1.4, and 3/2 root 2, which is about 2.1. So right here, you'll see that there's a little bit of symmetry here. All right, let's do pi. X is going to equal 2 cosine of pi is negative 1. Y is going to equal 3 sine of pi, which is 0. So that's this point right here. Now, I wish I had more space because this table needs to be a lot longer. So I'm just going to mentally talk you through what our graph is going to look like. So far, we are going to, here's another little tidbit here. When you're graphing parametrics, you are going to connect the dots in the parameter order. So as t increased, the points went here to here to here to here. So I'm going to put maybe a couple arrows on here. Arrows are indicating the orientation, okay? Now, if I were to keep going and do 5 pi over 4, I am going to get negative root 2 and a negative 3/2 root 2 So we're going to have a point right there. If I'm going to do 3/2 pi, I'm going to get 0, -3. So basically what I'm trying to get at here is that this is just going to keep continuing in this manner until actually we get back to here. So this set of parametric equations, okay, looks like it makes an elliptical shape, and we have an arrow that's indicating orientation, okay? So what is a set of parametric equations? Well, when we have a parameter that is dictating the values of two separate equations, in this case, our x equation and our y equation, then that is a parametric equation, and the parameter in this case was t, okay? Now, I'm gonna come over here. A note in my, and in most of your graphs, your arrows need to represent orientation. Okay, so the direction at which your graph is going with respect to the parameter. That's really the only way that there's a parameter reflected on the graph, because everything else on the graph is x's and y's. Okay, so the set of ordered pairs x, y, where x is a function of t and y is a function of t, forms a graph on a plane curve, right? And t is the parameter. We have ourselves parametric equations, okay?